Hi, welcome to this video on acids and base properties. So in this video, we're just going to talk about some of the properties, chemical properties of acids and bases that we can use to help identify them in the lab setting. We'll also talk about a couple that we shouldn't use to identify them in a lab setting. So first off, let's talk about reactions with metals. So one of the chemical properties of acids that we can use to identify it if it's present, is that they will come in, when they come in contact with an active metal, they'll always produce hydrogen gas. So we say active metals, that's where we have to use our activity series to figure that out. So they don't react with every metal, that's very important. There are several metals that are lower on the activity series, like copper and silver and gold, in which acids will not react with them. However, bases in their reactions will not react when they come in contact with metals. So you may see the substance become like it might shine something up because bases can be cleaners, but it's not going to actually create a chemical reaction with the metal itself. Then we also have reactions with carbonates and bicarbonates, basically anything that has CO3, the carbonate ion, or the bicarbonate ion. So these types of compounds, so it could be sodium carbonate like baking soda or something, react with acids when they come in contact and they produce CO2 gas. So you always see when this happens is you see bubbling. So you would definitely see bubbling occurring. You would also see bubbling, sorry I didn't mention that in the previous with the hydrogen gas as well. So when you react a carbonate with an acid or whatever, then you would see bubbling happen, but bases are not going to react. So it would be just a mixture and then you wouldn't see anything happen. Some other really important things that we can see. Now, we would not test this in lab, but with taste. Acids are going to have a sour taste. So if you think of things that you know that you have had, like citric acid, so that would be like lemon juice or anything that's citrusy, is going to have a sour taste. Obviously, we would not taste in lab because that would not be safe. Bases have like a bitter taste. Most bases are things like soaps and cleaners and whatever. I'm not sure very many of you have ever purposely attempted to eat soap, but it happens sometimes, and so it has kind of a bitter taste. The feel of an acid is it feels like water. There's no characteristic feel, so I'm going to put Na there. You can't use a feel taste for an acid or a feel test for an acid. So if you were to put that in an acid in your hand, it's just going to feel like water, so you wouldn't know. But bases have like a slippery or a soapy feeling. So when you put a base on your hand, it's going to have that slippery feel like when you don't rinse all the soap off of your hands. So bases have an easy one. Again, taste and feel are not lab safe, so keep that in mind. Those are not things that you would do in lab unless I was specifically telling you that the substance that you were doing it with was lab safe. But that's not something, a test you would ever perform in lab. Some other important things, pH, we're going to talk a little bit more. You guys know this a little bit from middle school. The pH of an acid is below 7. So if you have a pH that's less than 7, that's going to be acidic, and a pH that is greater than 7, you have a base. And so going up higher or lower. Litmus paper is a little piece of paper that you can put in there. You guys are probably somewhat familiar with it. So litmus paper, I'm going to put that on there, it turns red. There's different types of litmus paper, but it's going to turn red or stay red when you use it, and it's an acid, and it will be blue if it's a base. So those are your characteristic colors you would be looking for with litmus paper. Now keep in mind the colors change depending on the indicator you use. So litmus paper is one type of indicator we can use. Phenolphthalein, I know it's a big word. Phenolphthalein is also an indicator that you can see used that has a turning point that's right around a pH of 8. So it's not perfect for things that are really close to neutral. But if you're on like the obvious like acid or base end of the scale, it's pretty accurate. So with phenolphthalein, with acids, it's going to be colorless, so you wouldn't know that it's there. So if you put it into an acid, it's going to just be the color that it was, which is usually clear. And then if base it, when it's put into a base, it turns like a bright pink or a dark magenta almost. Sometimes that you see people, like the things will put red, but it's really like a pink magenta color. And that would indicate that it was a base. Obviously, the darker it is, the strong, like the more higher on the pH scale it's going to be. And then to review, acids are going to react with metals, most metals, not all, and carbonates, right? And bicarbonates. And bases do not really react. So there's no characteristic reaction that we need to know about bases when we're studying those. So acid bases, we can use all of those in the lab to help us identify if something is acidic or basic. There's a lot of other indicators as well, but these are just some of the more common ones that you'll see used. But there's also like universal indicator, which is really cool. Universal indicator gives you a rainbow of colors. There's pH paper, which gives you a range of pH that you can use. There's tons of different acid-base indicators that give you more or less information depending on what you're looking for. When we name acids and bases, we do have to know how to name them. So when we name acids and bases, there is two different, really acids are the tricky one. When you name acids, we have like a common naming system, but acids are basically, when we're looking at it, let me switch colors here so it's like, you can see I'm switching. So with acids, it's basically, an acid is hydrogen with some other, like a hydrogen ion and some other anion. I'm going to put an A minus. So it's some other anion or negative ion, okay? And it could be a single element or it could be a polyatomic ion. A binary acid is when you have the acid with only two elements. So that's going to be like hydrogen, right? A hydrogen ion, and then like a chlorine ion, right? Something that's like a single element. So like HCl, that's what we'd be looking for. So it has one or more electronegative element, right? So HCl, HF, H2S, like there's lots of options. Then in an aqueous solution, when you are naming a binary acid, you use the prefix hydro. This is the only time you use it, is if it's a binary acid. So here I would see that single element and I would say hydro, okay? And then the root of the name is the second element. So your root is always going to be based on that element, the chlorine or the sulfur, whatever it is. So it's going to be hydro, in this case chlor is your root, right? And then the ending is ic acid. Ic acid, okay? So super easy. So hydrochloric acid, if it was an F, it would be hydrofluoric acid. If it was an N, it would be hydronitric acid, whatever. Okay, so it's the hydrogen with the single element. Then we have oxyacids, and these are basically those with a polyatomic ion. So a hydrogen with a polyatomic ion. So it's going to be hydrogen, let's say, and an example, let's go with a polyatomic ion. Let's go with chlorite, right? So I've got hydrogen with ClO negative, right? So those two come together. I have that's chlorate. Sorry, we'll go with that one, ClO3. All right. I can also do it with the chlorite, which would be HClO2. All right. So either one. But basically, we got a polyatomic ion here instead with the hydrogen. So the biggest thing here is there's no prefix. So that means there's no hydro in the naming here. So that's the big difference. So no hydro. Okay. You just look at the element, right? So in this case, so let's say I'm going to do I'll do it down here, HClO3 first. Or actually, I'm not going to do it down there because that's going to be in the bases and that looks confusing. So let me scroll over here a little bit. Okay, I'll do it over here. So let's say I've got HClO3, right? And so when I see HClO3, I've got no prefix. I look at the root. The root is chlor, right? And then I look at what polyatomic ion this is. So this polyatomic ion is chlorate. That's the key, is looking at our polyatomic ions. So chlorate, right, is going to be, when we look over here at the 8 polyatomic ion, becomes ic. So it's going to be chloric acid. Okay. Let's say I have HClO3 or ClO2, which in this case is, when I look at it, right, is going to be the chlorite ion. Yeah. Okay, so notice chlorite. And so when we go to name, it's still chlor because that part, no prefix, but the ending changes. So we've got this ite polyatomic ion, the ending becomes OUS acid. So chlorous acid versus chloric acid. So the ending is telling you which polyatomic ion it is. All right, so this is something you do need to memorize, or you would want to make sure you clearly understand. Then we also have bases, which bases, there's nothing special about naming a base. When you're naming the base, you're just using, let me change my color. When naming bases, our base is going to be a hydroxide, right? It's going to have hydroxide in it. So anything with hydroxide. So I can have NaOH, right? So it'd be just like an ionic compound. Sodium's in group 1, so I would just say sodium hydroxide, right? Or let's say I've got Ba and then parentheses OH2, right? So that's 2 because barium's a +2, but it's still group 2. So it'd be barium hydroxide. So there's nothing really special with the bases other than their normal name. But acids do have a special naming system that you do need to know and be aware of. And on this page, there's just an overview of the properties of acids and bases. Gives you a little more in-depth pictures to kind of help you look at those. But you can also look at these online. So some of those different indicator tests that I showed you, pH paper, pH meter, how it works. So it gives you actual pictures to kind of see. But you can also look at these up online on your own. All right, so that is it for our properties of acids and bases notes and naming.